Okay, so in this video, we are going to talk about how to solve a one-step equation. Um, so it says, in order to solve a one-step equation, we must locate the variable, or no, I'm sorry, not locate, isolate the variable, and keep each side balanced. So inverse operations means the opposite. So the opposite of adding is subtracting. The opposite of subtracting is adding. The opposite of multiplying is dividing. And the opposite of dividing is obviously multiplying. Um, the inverse operation can be thought of as the opposite or undoing operations. So when we are solving equations, we need to get the variable by itself. So what I want you to do is first circle the variable. Two, draw a line through the equal sign. And then identify the operation that's happening. Okay? So in this problem right here, we located our variable. We draw a line through our equal sign. Okay, so the whole point of drawing the line is to show you, and so that you can visually see what happens on one side of the line also has to happen on the other side of the line. And so we want to, as it said on the previous page, we want to isolate the variable. And so to do that, we have to undo the operations that are happening. And so to do that, we perform the inverse operation. So if I have 4x, okay, 4x can also be read as 4 times x. And so if this is a multiplication problem, to undo multiplication, we are going to divide. And if I divide by 4 on this side, I also have to divide by 4 on this side. So this cancels out, and we're left with an x on this side. Negative 16 divided by 4 is negative 4, and that is our answer. So the whole point of doing this is when you are multiplying or dividing, we want to make 1. When we are adding or subtracting, we want to make 0. So what I mean is 4 divided by 4 becomes 1x. Well, 1x is the same thing as x, okay? But in this problem, we're going to circle our variable. We're going to draw a line through the equal sign, okay? So we need to make 0. We need to turn this 9 into a 0 because we are adding or subtracting. So in order to make 0, we need to subtract 9. And whatever I do on one side, I have to do on the other side. And so this makes 0, so it cancels out, and I'm left with x equals 4. All right, the next problem. Okay, so we are subtracting 8 on this problem, And so to make 0 and to get rid of that 8, we have to add 8 on both sides. So x equals 12. All right, this one looks a little bit different, but if you remember from the very, very beginning of the year, we said that fractions always mean divide. So this is x divided by 5. And so if I'm dividing by 5, then I need to multiply by 5 on both sides. So this cancels out. We get x equals negative 30. Okay, so this right here sometimes confuses people because they say, well, 5 times 5 is not 1 because our goal is to make 1. 5 times 5 is 25. Okay, but really what we have going on here is 1x over 5. Okay, so really it's 1/5 x. So to undo this, I need to multiply by the reciprocal. Okay, the reciprocal is just the fraction flipped over. So I would get 5 times 5 is 5. 1 times 5 is 5. And that simplifies to 1. All right, next problem. Okay, so we are subtracting 6 in this problem. So to undo subtraction, we need to add. And we get x equals negative 5. Okay, so this one's a little bit different. So sometimes people try to add 2, but the way that this problem reads is negative 2 times x. So always look between the number and the variable, and if there is no operation between the number and the variable, then it's a multiplication problem and we have to divide. And we don't just divide by 2, we have to divide by negative 2 because we also want to cancel out that negative sign. And so we get x equals, sorry, this should be negative 2 also. Negative 2 divided by, or negative 4 divided by negative 2 is 2. All right? And you have to show your work. I know on one-step equations that you guys could probably just do it in your head, but you need to practice showing your work on these easy problems so that as we build on and the problems get more difficult, you know how to show your work. Okay, so one-step equations can also include rational numbers. And we still just solve it the exact same way. Our line through our equal sign, we circle our variable. So this is a multiplication problem, so we're going to divide by 6. And we get x equals, I don't have a calculator next to me, so 16 divided by 6, it goes in there 2 times. Okay, and so that is going to be 2.6 repeating. Okay. On this one, it's an addition problem, and so we're just going to subtract 2.5. So this cancels out, and we get x equals 5. This problem right here is very similar to the one that I showed you on the previous page, except, so when I reworked it out, I showed you that it was the same as 1/5 x, okay? So we have 2/3 x. We want to make 1, okay, because we want to end up with 1 times x, because 1 times x just gives us x. So if I am multiplying by a fraction, like we are in this problem, then we are going to multiply by its reciprocal. okay? And we're going to do that on both sides. So we end up with 6 over 6. 6 over 6 is 1. So that leaves us with x. Okay? So then to multiply by a fraction, you multiply by the top, divide by the bottom. So 8 times 3 is 24. Divided by 2 is 12. So that is our answer. And then the last 3. So again, we are dividing by 3, which is like dividing by 1/3. So to undo dividing, we're going to multiply. And we get x equals negative 21. Okay, so this is a subtraction problem. So to undo subtraction, we're going to add. So add 1.6, add 1.6. Okay, so here it's super important that you follow the rules, though, that we worked on in Unit 1, because we have a negative number and a positive number, so you end up subtracting. Okay, so it's 6.6. X equals negative 6.6. Okay, so this is a multiplication problem. Negative 4 times x. So we divide by negative 4 on both sides. So this cancels out and leaves us with just x, and then negative 2 divided by negative 4 is a positive 0.5. All right, and our last problem, it says if a chocolate pie is divided into 6 equal pieces. So when we're doing word problems, I would like for you to underline or highlight important parts. So it's divided into 6 equal pieces. Each slice has 280 calories. How many calories are in the whole pie? So one-step equations are really, really tricky to write. So what we know, that it was divided into 6 pieces. Okay? Each piece has 280 calories. Okay? What do we need to know? How many calories in the whole pie? Okay? So you can easily, you know how to solve this already. Normally you would just solve it and do, okay, well 6 times 280 would tell me what's in the whole pie. But we want to write an equation, okay? So when you go to solve this, your gut instinct tells you to multiply. So when I write my equation, I'm going to do the opposite, and I'm going to divide. And so we need to start with the whole pie. We don't know what that is, okay? So we're going to use a variable to represent that. Well, the whole pie was divided into 6 pieces, and each piece was 280, has 280 calories, okay? So we just wrote a one-step equation. So then to solve it, we draw our line. We're going to multiply by 6 on this side. We're going to multiply by 6 on this side. Okay, and you should get 1,680 calories in the whole pie. All right, you will go and grab the quick check that says, how do you solve a one-step equation?